going to take a look at multiplying polynomials. Now, multiplication of polynomials is easier than the division of polynomials. We'll be able to multiply terms, two polynomials by one another, multiply binomials. We'll also learn about a special case of the product and sum of terms and product or difference. And we're going to look at how to square a binomial and how to multiply polynomial functions. So first, let's look at multiplying terms. First thing we need to do is we know what 8 times 9 is. That's not the hard part. What is k to the third times k? If you remember your exponent rules, when I multiply two bases that are the same, I add their exponents. So this would be k to the fourth and y to the fourth, because 3 plus 1 is 4 and 1 plus 3 is 4. So you really have to make sure you remember that exponent rule. Now, to multiply any two polynomials, we're going to use the distributive property, which means you're going to distribute everybody is going to get that first term. So negative 2r is going to be multiplied by 9r, and it's going to be multiplied by 5. Then we're just going to follow our multiplication rules. Negative 2 times 9 is negative 8. R times r is r squared because I have 1 plus 1. Negative 2 times negative 5 is 10, and then the r is remaining. Now I have two binomials, but the principle is the same. I'm going to distribute the 2k to each term. Then I'm going to distribute the 5 to each term. So 2k times 3k would be the first times the first. Then I'm going to have 2k times 2m. So they're written in a different order, but you can write them in any order. Then I'm going to have negative 5 times 3k and negative 5 times 2m. And I'm going to simplify that. Then I'm going to combine my like terms. So what you're doing is you're giving every term in the second parentheses a distribution of the first term. Here's another example. This one we have written vertically. It's just a little bit easier. And then I'm going to multiply negative y times each term. I'm going to multiply 3x times each term. And I'm going to add them together. I don't like looking at the vertical part of this. So if a question came up that was vertical in the lab, I would actually write it next to each other because I think that distribution is a bit easier to see. So everyone's going to get a negative 5, everyone's going to get a 2a, and I'm going to add them together. I think that when you write them vertically, it's not as easy to see the distribution as it is when they're next to each other. So to multiply binomials, a lot of people know the term FOIL. I personally do not like the term FOIL because it's just distribution. Why learn a whole new name? Why memorize something new when we're just distributing? Look at this diagram here. I'm doing 3x times 3, and I'm doing 3x times 2x. Why don't we just call it distribution? That's what it is. So I'm distributing 3x times 2x, 3x times 3, negative 4 times 2x, negative 4 times 3. So I don't really encourage you to try and learn this FOIL method. Just distribute. That's the beauty of this. So I'm going to distribute 5r to 2r and 5r to 5. And they're going to classify this as first, outer, inner, last. But look at this, 5r times 2r, 5r times negative 5. It's the same thing as distributing. Then I'm going to have negative 3 times 2r, negative 3 times negative 5. So don't stress yourself out trying to learn this mnemonic thing. Just distribute. And then once you've distributed, you will have to combine the like terms in the middle. That's going to be pretty standard. The middle pieces are going to combine. Here's another example. They've labeled them first, outer, inner, last, but I'm really doing 4y times 2y, 4y times 3z, negative z times 2y, negative z times 3z. And then I'm going to have to combine my two middle terms. Now, this is a special case, and this is really difficult if this is the first time you've seen it to recognize it. So I want to talk for a minute about how to recognize this. If you're looking at the left-hand side of the equal sign, notice it's the exact same thing. I have x and y in both parenthesis sets. The only thing that's different is the sign in the middle. When that happens, you don't have to distribute. You can square the first, square the last term, and put subtraction between them. So what does that look like? Notice I have m plus 5 and m minus 5. So I have m and 5 in both parentheses. I have two different signs. So I can square m to get m squared, square 5 to get 25, and I subtract the middle. So distribution will get you to the same answer. It absolutely will. It's just going to take a few extra steps. So this is just something that you can choose to remember. Here's another example. If you remember the shortcut, you can square the first and square the last. And you're going to get that. Here, I have two things happening. I have that square the first, square the last, but then I still have to distribute the 4y through. So you want to basically take care of that multiplication of the parentheses first, and then distribute your 4y through. Now, let's talk about squaring a binomial. So this is where the instinct here, when you see x plus y squared, is to do what we just learned. But x plus y squared is not equal to x squared plus y squared. For the same token, x minus y squared does not equal x squared minus y squared. So you can't just square the first and the last because you have to have two different signs in the parentheses. So when I have t plus 9 squared, that is t plus 9 times t plus 9. So you would distribute it through, and that's where this is coming from. Or you could use the shortcut method, which we saw here, which is x squared 2 times x times y and y squared. So you can use either the shortcut or you can rewrite it as t plus 9 times t plus 9. The same thing is true for part B. You can use the shortcut or you can write it as 2m plus 5 times 2m plus 5. And then you're going to do the distribution. So those are some other examples. Here, notice we're adding on additional steps of what's happening here. So we're adding on, now I've got this x plus y minus z, and I've got this x minus y minus z. So what I'm doing here is I factored out x minus y. That's what's happening here. It's been factored out. So I'm left with a plus z times a negative z, which would be negative z squared. I can simplify the first parentheses and get my final answer. Here, I'm looking at this cubed, which would be p plus 2q times p plus 2q times p plus 2q. And you're going to distribute it each time. So here, I did the p plus 2 cubed squared, and I'm going to give everybody a p squared, everybody a 4pq, everybody a 4q squared. And then I'm going to simplify. Yes, you will see these in the lab. The key is to take them one at a time and step by step so that you can then get the correct answer and to use the distributive property. Absolutely. Same thing here. This would be those terms squared and the additional terms squared. I'm going to distribute. Once I've expanded them out to the squared, I'm going to distribute them through, and then I'm going to combine my like terms. And it's a pretty big statement. There's not a lot of these types of problems in the lab, but there are a handful, okay? So taking it step by step is going to be really important. If I want to multiply polynomial functions, I'm going to distribute. So this is multiplying in function notation. There's nothing written between f and g. So when you see f of g, you're going to distinguish between f times g because they're just written next to each other. So it means to multiply the binomial, which we're going to distribute and combine our like terms, just like we just did. So it's just distribution. If I want to know the value at 2, I'm going to replace x with 2 and get my final answer of negative 7.